Hi, eights. Going to do a lesson today on different types of matter and fluids in your textbook. 1.2, page 13 to page 16. It's all about fluids. You have check and reflect questions, numbers 1 through 3. On page 16, and then I'm going to look at section 2.0 as well, and that is page 18 through 23. Yeah, 18 through 23 in your textbook. We'll look at, we might go page 24 as well, concentration and solubility, to page 28, but we might not get that far today in this lecture. So let's start with just some information about fluids. So fluids and their uses. So a fluid itself is anything that has no fixed shape and can flow. So that could include liquids and gases, and in some cases, very, very slow-moving solids like glaciers or ice fields. Okay, so you can see some examples here, right? Water, soup, oil, yada, yada, yada. Fluids, because they take the shape of their container, are easy to transport. And we use them in varying different concentrations. We're going to talk about what concentration is and the reasons why we use different concentrations for different things. So think of this. Some things become fluids at different temperatures as well, right? So glass is a liquid at 1,000 degrees Celsius. We can liquefy it, becomes a fluid, and then it'll solidify into the panes of glass or the use of glass that we need. So glass is a mix of sand, limestone, generally carbonates, but also silicon. Right, the silica is what's in the sand. Steel, right, is a liquid at 1,650 degrees Celsius. Steel is a combination of iron, carbon, and things like titanium or other different types of metals. There's different types of steel alloys depending on what the other component is of the steel. Okay, but it's always iron and carbon and something else. Right, so materials have different properties based on their temperature as well when we think about fluids, so keep that in mind. Okay, so inside toothpaste, right, we have multiple different types of fluids, right? So you have something to clean your teeth, right? Fluoride, right? So there's different things that are dissolved into the fluid itself. This is the example in your textbook. Okay. That's all we're really going to talk about with that section. So just introducing yourself to fluids. It would be good if you read pages, like I said, pages 13 through 16. Okay, so that example of toothpaste is talking about how fluids can hold other materials inside them. And that's called dissolving, and we'll talk about dissolving more as the lecture goes. So when we look at matter itself, right, this is the start of the chemistry unit, so we have to define what matter is. Matter is anything that has a mass and takes up space. So there are things around us that do not have mass and do not take up space. Something like light. Light is all around us, but it doesn't have a mass, nor does it take up space, right? So matter has to have a mass. It has to be, meaning it has to be composed of particles, and those particles have to take up some sort of state. All right. Generally, we have 3 states of matter: solid, liquid, and gas. We'll talk about some modifications to that, though. You could have plasmas, which are really high temperature. They're generally high temperature gases that act a little bit like a liquid. You could also have colloids, which are a combination of a solid and a liquid. Okay, but when we look at matter itself, matter is divided into mixtures and pure substances. Okay, so matter is divided into mixtures and pure substances. Pure substances are elements that you find on the periodic table and compounds. So combinations of elements, but the pure substance itself only contains that single compound. All right, there's nothing else mixed in it. Mixtures have there's different types of mixtures. Okay, so with a pure substance, if you look at these examples here, so there's two or more substances mixed together in a mixture, and with pure substances, there's only one type of matter, and you can't separate it into smaller component parts. So you can see that here: sugar, aluminum, foil, water, yada yada yada. All that's in the aluminum is the aluminum. If we look at distilled water, the only thing that's in, right, that would be a compound, H2O. So distilled water, the only thing in distilled water is water. There's no minerals or anything else inside it. And elements is anything you find on the periodic table. Okay, so in your notes here, with mixtures, we can have mechanical mixtures, solutions, or suspensions. Okay, so you can have mechanical mixtures. And with the mechanical mixture, you can see the different component parts. You can have solutions where there's one thing dissolved into another thing. So there's generally a solute dissolved in a solvent. So any like solution that I would use in a lab where we have, a compound or an element dissolved into water. Think about things like vinegar or Kool-Aid or coffee or tea, right? Those things are all the things that are dissolved in water itself. And you can have suspensions. Okay, so a suspension is something in which you have droplets or tiny pieces of one substance, and they're held within another substance, so it looks like one thing, but if you let it sit, it'll settle out. A good example would be, I give you the example here, soil and water and clay and water. But another good example of a suspension that you'd see every day would be something like orange juice with pulp. If you mix it up, then then you can see the pulp sort of dissolve into the liquid itself. But if you let it sit, then it goes away. Right, then the solid pulp will separate from the liquid water. Chocolate milk is a good example of that in some cases if it dissolves out. Right, so there's lots of different types of examples of suspensions. Muddy water is probably the easiest one. And then you have colloids. Okay, so a colloid is a combination. I'll show you a colloid when you guys are back in class. But a colloid is a combination of a solid and a liquid, and it does not settle down when left alone. So chocolate milk could be, right, if I'm gonna drop the Hershey Quick into milk or whatever, you can see it separate after a while. But if I buy chocolate milk from the grocery store, that would be a colloid. It's solids dissolved in a liquid, and they don't separate out. Mayonnaise, right, is another one where you have solids spread out throughout a liquid. Cornstarch in water is a really good one. It has properties of solids and liquids, and I'll show you that when you guys are back in class. Okay, so those are your different types of matter. Okay. This is page 19 through 23. Okay. Hopefully we'll be able to do a lab on chromatography when you guys are back. We'll also try to do a lab where we make slime. Section 2.2 looks at concentration and solubility, and that'll be the last part of this lecture. This is page 24 through 28. Okay. So, first thing we need to consider when we look at concentration. So concentration is how much solute is dissolved in a solvent, or how much stuff is inside a liquid. Solubility is the ability for something to dissolve inside a solvent. Okay, so this just shows you this right here. So this is salt plus water. So the salt dissolved in the water. The thing that gets dissolved is the solute, and the thing that does the dissolving is the solvent, and we get a solution from the two of those combined. Okay. So if we have more solute in a solvent, that would be a more concentrated solution, right? If there's less salt in, right, the less solute inside a solvent, that would mean a more dilute solution. Right, so here's a common example that you might have used at your home, right? Sugar plus water, right? Or adding, refined sugar, Kool-Aid, drink crystals into water, right? The Kool-Aid crystals would be the solute, and the water would be the solvent. And I could change the concentration of that, right? If I add more Kool-Aid to make it taste more sugary, that would be a more concentrated solution. And if I were to add less, and it would taste more like the water, that would be dilute. There would be less solute in the solvent. Okay? So concentrated versus dilute. Concentrated means more solute per unit water. That would be concentrated. So there's a large amount of solute and less amount of solvent. Okay. It asks you to write 2 examples of concentrated solutions. One way that we could concentrate water is, right, if we wanted to make a really sugary solution of Kool-Aid, is you could boil the water and add the Kool-Aid while boiling, because the particles, as they heat up, spread out. So you could actually fit more Kool-Aid in there with the water being heated, and then it would cool, and it would be a supersaturated solution at a certain temperature. It would cool and have more sugar attached to the water as a result. Right, so concentrated. Dilute means there's less amount of solute, right? So the solute is the thing that is getting dissolved. The solvent is the thing that does the dissolving. Right, so less solute and more solvent is dilute. Saturated means that there is a very, very large amount of solute, and no more solute can dissolve. And this is what I'm talking about with the Kool-Aid here. If I wanted to add more solute into my Kool-Aid solution, some more drink mix, I could heat the water up and it could fit more solute into it, because the particles would be spread apart because they would be moving faster if I heated the solution up. So no more solute can dissolve. And what you'll start to see, right, is rather than the molecules dissolve into the solution, you start to see little solids build up on the bottom. Okay, so no more solute is permitted inside the solvent, and that's based on the molecule's properties, right? Some things will be able to dissolve more than others, and it's totally dependent on the solute-solvent relationship between what's getting dissolved and what's doing the dissolving. You should understand what these mean. Saturation point is the point where no more solute can be added to a solvent. That will be where you start to see solids build up on the bottom of something that you're trying to dissolve. Right, so this leads us to concentration, the conversation about concentration. So concentration is the amount of solute that's dissolved in a specific amount of solvent. All right, so the amount of solid dissolved in the amount of solvent is what we call concentration. So we use grams per milliliters generally. There's different types of concentration that we can use, but for our purposes in junior high, we'll use grams per milliliter. Right, so 50 grams per milliliter per 100 mils of water is the concentration there. So if I were to do my math with that, right, so if I have 50 grams per 100 mils, right, this would end up being, I did the math, this would end up being 0.5 grams per milliliter. So that would be my concentration. Okay, and we can obviously compare concentrations. Right, so how do we compare concentrations? Right, we have a 5 gram per 50 ml solution and a 10 gram per 200 ml solution. You could do this if you wanted to, or you could just do the math. Right, so if I have 5 grams, so here's my two examples. 5 grams per 50 mils and 10 grams per 200 mils. The question is, which one is more concentrated? Right, 5 grams for 50 mils and 10 grams for 200 mils. Right, this would be 5 grams divided by 50 mils and 10 grams divided by 200 mils. And we look at which solution is more concentrated. Let's do the math. All right, 5 divided by 50. So I have 0.1 grams per milliliter for solution 1. And that's the other solution is 0.05 grams per milliliter. Okay, so solution 1 is more concentrated than solution 2. Even though there's a larger amount of solute, it's dissolved over a larger volume, right? So here there's less solute, but it's dissolved in a smaller volume, so that makes it more concentrated. So there's more solute per unit solvent here. So this is the more concentrated solution. Okay, pretty simple stuff. Anyway, I'm going to end the lesson there today. So that goes to that section goes to page 28, looking at concentration and saturation and dilute versus concentrated solutions. You have questions page 1 through 5 on number 28. All right, so that's kind of the introduction, another introductory lesson to chemistry. We'll talk about this more in another lecture, and we'll hopefully do some labs, and you guys are back next week. Anyway, have a good one. Bye now.